Everyone. So as we start this next chapter, we're looking at systems of equations, and we're going to start out graphically. A system is when we have two or more equations that are bound together, so we're looking at multiple equations at a time. When we do have a solution, so if there is a solution that exists, the system is said to be independent. Otherwise, we have something that's either dependent or inconsistent. So there really should be two blanks here. So if we look at this first graph, you can see that there are two lines or two linear functions that are going on. We have a red linear function and this blue linear function, but they intersect at one point. So we can see this intersection point is the value, in that case, it's an xy coordinate that would satisfy both equations for the two linear functions. When we have a graph of two linear functions that are parallel, we look to see, well, when are they going to intersect? And because they're parallel, they will never intersect. So in this case, there is no solution to that system. That system would be considered inconsistent. If we are graphing the two lines and they end up being the exact same, they are two lines on top of each other, this is what we would call a dependent system. The answer would depend on that specific relationship between x and y that's forming the line. So any point on that line is a solution. We have infinitely many solutions. And we're going to talk about how do we create or how do we explain what the infinitely many solutions are, because while there are infinitely many, there's a specific relationship between x and y. So we would typically graph by hand, but if we have access to technology, we want to use that technology. So we're just going to look at Desmos real quick and graph the systems and then look to see if we can find the solution. So we have this first system. This is what the two equations might look like. And then I would graph them. With Desmos, it's very nice that you can just type it in the way it is. And we see we have these two linear functions, and they intersect at this point 1, 2. So the answer, or the solution for this specific system, would be that coordinate 1, 2. The reason why Desmos is going to make this so much nicer is because we're not having to do this by hand. But if we did have to graph specifically by hand, I would have to solve this equation for y. I need to get y by itself. And so I can move that x to the right side and make that negative x plus 3. This second equation is actually already solved for y. It's just on the opposite side, but it's y equals 2x. And we would have to graph both of these on a coordinate plane. That would mean I need to use the slope and y-intercept to graph that one line that's going down, and then the other line going up, and we would find when they intersect. And it should be at that point 1, 2. So go ahead and pause the video and find the solutions for 2 and 3. All right, if you've already done it, then you have, let's see, a solution for the first one here at 2, negative 2, well, for the second one. And then the third one, we have this green line, and as I'm looking, I'm wondering, well, where did that other line go? You can toggle off the green line and see it's underneath the green line because the red and green are the same equation. So there are infinitely many solutions for number 3. We don't have to have just linear equations. We can have a nonlinear system. So this graph I can see has a quadratic, this parabola, and a linear function. And they do intersect twice. This has a solution at 0, 0, and another one at 2, 4. So there are 4 graphs here, 4 different systems. And you want to look to see, can you identify all of these solutions to this system? So if you pause real quick, you can write down your solutions and then check your answers. All right, so we had a solution here, this intersection point at -3, -4. And then we have another solution up here at +3, +4. The part B, question B here, has a solution at -4, 3. And then another one here at +4, 3. For C, there are still 2 solutions. It happens here at -4, 0. And then another at +4, 0. And last one here, we have 2 solutions. This one's at 2, -2. And then we have another one at 8, 4. So graphically, it's not too difficult to find where they intersect, but we want to also look at how do we solve systems algebraically next.